Hello and welcome to another video. In this video we're going to be working on check if parentheses string can be valid. And in this one, a parentheses string is a non-empty string consisting of only open and closed parens, and it is valid if any of the following are true. It is an open and closed paren, or just basic definition of parentheses. So it's essentially every closed parenthesis has to be matched by an open parenthesis, and that's basically it. And then you have to have the same count of open and closed parentheses, and yeah. So just normal parentheses. And it would help to do like an easier problem if you haven't done this one before. Just like do like valid parentheses or something where you don't have this locked thing. That would make it easier. So basically the idea here is some of these parentheses can be changed and some are fixed. So the ones that have a locked of 0 can be variable, and the ones that don't can be so the ones that have a lock of 1 have to stay the same. And you're basically asked, can I have this be a valid parentheses? So essentially you can almost treat the unlocked as like a star. So instead of like this character, it doesn't really matter because we can just change it to whatever we want. So basically, like in this example, our thing is like this. So this is like a star character. This has to stay fixed. This is a star, fixed, star, star. And then just figuring this out. So because there's a closed parenthesis here, this has to be open parenthesis. And because there's a closed parenthesis here, this has to be open parenthesis. And now there's 2 stars left, so you can just match those together with an open and closed. And then here, clearly, whenever everything is unlocked and you just have an even count of parentheses, you can always make it valid, right? Like this doesn't matter what this would be. You can always just make it valid parentheses. You can make it whatever you want. And then here, you can't make it valid because even though you can change this, there's only 1. So the really obvious constraint is just like if there's an odd number, then this is just false, right? Because you need to have a matching pair of parentheses for every single parenthesis. But there's some other tricky stuff, like can we have like a greedy solution or something? So here the constraints are 10 to the 5th, so you need like a linear solution. And just thinking about like all the algorithms you can use, probably not going to help to use some kind of like binary search or something. I mean, it depends how you do it, right? But actually there is kind of a way to do binary search, but not going to be super helpful in most cases here. And then you can't really do DP because you can't keep track of like 2 things. You can't keep track of like how many stars you have and like what index, because that would be too big. So essentially you're looking for some kind of greedy or like or if you know how to solve the valid parenthesis, like a stack solution or something like that. So there's actually a way to do this with a stack. And I'll talk about that, and then I'll talk about kind of like the simplification from the stack to an O1 solution. And I thought of the stack one, I actually didn't think of the O1 solution, but it makes a lot of sense once you see it. So essentially, with a stack, let's just say we have some random like thing, like I guess, let's just say we have, let's see, we can just make some random thing. And basically, I'm not going to draw these 2 arrays. I'm just going to draw open parentheses, closed parentheses, and stars. And stars is basically just like the same as unlocked. Because if it's unlocked, you don't really care about the character. And if it's locked, then yeah. So essentially, let's just have like open paren. And here, say open paren, open paren. I'll have some stars here. And then open paren, and then something like this. Closed, closed, open, star, something like that. So how do we know if this is valid? Well, ideally, what we can do is whenever we encounter a closed paren, we can just check like is there an open paren that we already have, and those are the ones we want to match first, because the stars can be whatever we want. Like the stars are going to be easier to match than things that are already in place. So essentially, what we can do with a stack solution is we can basically just have 2 stacks. So one stack is going to be a stack of open parens, like a normal valid parenthesis problem. And then the other stack is going to be these stars. And then whenever we encounter an open paren, we can just put it on those. Whenever we encounter a star, we can put on those. Then whenever we encounter a closed paren, we'll just say, okay, let's try to match it with an open paren first, because those are the hardest ones. And then if we don't have that, then we have to use a star. And then at the very end, we're going to have open parens and stars, and we have to make sure that those are valid. Because for example, if you have something like this, like this wouldn't be valid, right? So you have to make sure that like every open paren left that's unmatched actually has a star behind it, because then we can turn it into a closed paren. And then if we just have stars left over, then as long as you have an even number of stars, you can always match those, right? You can always just go open, close, open, close, open, close. So let's kind of walk through how this would work, and then let's talk about the efficient or the O1 space. So here basically we have an open paren. So we're just going to put an index on our open paren. So we call this like open. We call this stars. So this will just be index 0. We're going to put that on our stack. Put index 1 on our stack. This is a star. This is a star. This is a star. So we'll just essentially have 2, 3, 4. Now we have an open paren again. So index 2. And then now we have a close. So whenever we have a close, we're going to try to pop off the opens first. So we do have an open paren. So basically, like, this is going to match this. So we can even draw that. Like, these two, or we can cancel it out. Like, these two are going to be a match. Then we have another close. So we're going to try to pop off the opens. We have one. So these two are going to be a match. Then we have an open. So we're going to add that to the opens at index 8. And then we have a star at index 9. Okay. So we were able to match every closed paren, but now we have to make sure that we actually can match every open paren as well, right? And the way to do that is we can kind of just like greedily walk through the open parens, and we can just say like, what's the easiest way to make sure there's there's a closed paren behind the open paren? We'll just say we'll take the rightmost open paren and we'll use the rightmost star to match that. So we can go back to the picture here. So essentially we're going to take the rightmost open paren and the rightmost star, and the rightmost star has to be to the right of the open paren, right? Because if you have an open paren, you have to make the star closed. So we do have that. So essentially these two now will match. And we're going to pop those off. And this one also has to have a star to the right of it, which this one does, which you can use the rightmost ones as 0 and 4. Essentially, these two. And now that so if we weren't able to get rid of all these open parens, we can return false. If we were unable to match a closed paren, we can return false. And now we just have to check, do we have an even number of stars? And if we have an even number of stars, we can just match those all together. Like, that's pretty easy, right? So those are kind of the constraints, basically. Yeah. So the O1 solution here is, instead of having these two stacks, if we go through this left to right, we don't actually need stacks, right? All we need is a count here. So we can just have a count of open and closed parens. So we'll have like this be x, this be y. And if we were able to go through this, then we know for sure that every closed paren was able to be matched. So that part is satisfied, right? Because we can do the same kind of thing. Whenever we hit a closed paren, we'll just say like, do we have an open? If yes, subtract 1. If not, subtract 1 from the stars. And if we don't have either, then we return false. Now, we can go through this really quickly. The way to make, like, the problem with this, that, like I said, for this, that we're missing if we don't do the stack, is we might have some case where we actually have unmatched open parens still, like, you know, like this case, for example, where like we were able to match every closed paren, but we have something like this is still invalid. And the way to fix that is basically we can just traverse the other way now and do the exact same thing, but now we treat it the opposite. So essentially the open paren will now be this guy and the closed paren will be this guy. And then if going forward is true and going reverse is true, going forward made sure that all of these closed ones are validated. Now going backward, we'll make sure that all these opens were validated. So let's walk through how this will work really quickly, just having a count. So essentially we're going to have 1 star, so we'll just up the count. So here we have a open paren, which is now, so this is actually now going to be the closed parens technically that we're keeping track of. So if we have an open paren, if we're going backwards, this open paren has to match a closed paren that we had already or a star. We don't have any closed, so we're just going to match it with a star, so we're going to subtract here. Now this is a closed paren, so we're going to add it here. Closed paren again, add open paren, try to get rid of a closed. We have 1. Star, 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 so now we have 3 stars. And then we have the open paren, so we're going to get rid of the closed. And then we have another open paren, so we can't get rid of a closed, so we'll get rid of a star. Then we just have to make sure as well the stars are even. And it is. So that's the solution we're going to go with, this O1 space, where we're just going to keep track of like the open paren, depending on from which side. Left to right, it's going to be the open paren. Right to left, it's going to be the closed paren. And just subtract accordingly. We're always going to subtract from the one that we can't change. And then just make sure that we have an even number of stars at the end. Yeah. Because basically, or I guess So if you do have, like, let's say you had too many open parens or something here, you're not going to know for sure that the open parens are fine. So even though there might be a number left over here, but that's fine, right? Like if we have some leftover open parens doing this way, like this is 5 or something, it's fine. But when we traverse backwards, we're not going to be able to match all these 5, and then that's how we're going to know that it's not right. So the only thing we have to concern ourselves with basically is, actually, we don't even have to concern ourselves with the number of stars is even or not. We can just check, is the length of the string even. So basically, if every closed paren was able to be matched left to right, and if every open paren was able to be matched right to left, and the length of this thing is even, then we're good. We don't even have to check if the stars is even or not at the end, doing it this way. With a stack, we do. Okay, so let's code that. So first thing, we can just check if the length of the string is odd, we can just return false. So now we're going to have these two variables, so we can call this like the open and the unlock or something. Okay, now we can loop through this going left to right, and then we can basically copy the code and go the other way. Alright, so if locked I equals 0, then we don't care what it is because this is just a star. So open, we in fact, we can even, yeah, let's just call this like star. Opens and stars or something. Okay, so if this is 0, this is just stars plus. All right. Now if it's a closed paren, or sorry, if it's an open paren, then we can increment the opens. So opens. Okay. Now the last thing, we have to make sure, like, we're gonna ideally get rid of one off of these if it's closed. So if it's closed, we want to get rid of the ones that we can't modify. So if opens greater than 0, open subtract. Otherwise, if stars is greater than 0, stars subtract. Otherwise, return false because we can't match this. Okay, and that's literally all. Now we can reset it and just go backwards. So we can copy all of this and basically just move the logic a little bit. So this is all 0, 0. Instead of going this way, we're going to go this way. Yeah, this one. Bring to 0. Subtract. Same thing, if it's unlocked, we're going to increment stars. Now, though, the open is this one going the other way. And yeah. And then that's it. So then if we were able to go through these loops, we can return true. We don't have to care about like how many stars we have left, how many opens, because we basically validated every left parenthesis can get matched and every right parenthesis can get matched. And the count we validated up here. So in fact, to be honest, I think even if you got rid of this, this would still work because these just wouldn't get validated. We can test really quick. This is just like an early return. Let's see. Is this then? What's the error here? Undefined I. Maybe didn't close this or something. Curious if this part works. Okay, that part's fine. I don't think it's this. Yeah. So I probably like misspelled something. Let's see, oh, I did minus I. Okay. Oh, okay. So actually, yeah. So if everything is a star, actually we do need this because so let's send that back. Because like if everything was a star, we still need an even length. And these would get validated if everything was a star, but it still wouldn't work. So we actually do need that. Okay, there we go. Okay, so yeah, this is going to be n time and L1 space. And I do think it was a little bit tricky to come up with this one, but once you see this for these parens, that you're like, oh, I can just, because normally what you do is for every closed paren, you make sure there's an open one in front of it. But now you can realize it kind of works the same way going the other way. So I don't actually need stacks for like any of these things. I can just, yeah, I can just have it count. So actually, if you did like validate parentheses or something, you don't need a stack because you can just have it count. And it would work. So yeah, you just go left and right. So hopefully this is like, gives you an idea of how to solve harder problems doing this kind of strategy. Yeah, okay. So yeah, it's going to be all for this one. Hopefully you liked it. If you did, please like the video, subscribe to the channel, and I'll see you in the next one. Thanks for watching.